This is Priyesh Sharad, 31208290, and this is the video presentation for Assignment 1, FIT5225, Creating and Deploying a Math Web Service within a Containerized Environment. We will start with the web service, which is the RESTful API server on the right side and has been built with the help of Flask. Flask is a micro web framework written in Python, and it is classified as framework because it does not require any particular tool or library. The purpose of this RESTful API server is to enable it to receive the post requests, which are in the form of two numerical values, one which consists of the matrix size and other the seed number. Using the seed number, we have to generate a matrix of n number of rows and n number of columns. And pretty much we have to use the numpy library to get the matrix of the size that has been sent via request. Further to it, we have to calculate the dot product by multiplying the matrix with the transpose. Matrix to raise to the power 3 into transpose of the matrix, and we have to extract the trace from the result. In between this process, we have to calculate the time taken for such processing, and to return it, we have to return the ID, we have to return the result, the matrix, and the processing time. This service is only meant for post requests. And whenever a client tries to send a GET request, he might receive a message that this is a math service and is meant for post requests only. Now moving on to the Docker file, as we can see here that here is the requirements.txt file. These files contain the library names that are needed for running our program successfully, and they are Flask and NumPy. Flask for building the application and NumPy for generating the matrices and performing all other numerical operations. In the Docker file, you can see that first step involves pulling of the Python image with the version 3.6. This version was the most compatible with all the kinds of libraries as of now, and using a bit more later and older version can cause problems to our program. Later on, we created a work directory called code, and we added the web service Python code in that created directory. Then we copied the requirements into that same directory, and also we upgraded our pip so that there are no problems installing the libraries that are in the requirements.txt. Lastly, we executed the command line with the help of this uh, Python and Core REST API, which help build our image called math service with the command that you can see there. The image was successfully built, and therefore we could use it for our next step, which was to deploy it on the Kubernetes cluster. This cluster and Kubernetes service, first of all, I had to create a cluster with the help of Kind, and certain configurations were also kept in mind while creating it. As we can see here in the config.yaml, that this was the API version that we used while creating the cluster, and there were two nodes. One was the master node and other was the worker node. It was important to keep the extra port mappings in mind so that the whole system might work as one when we have to deploy it as a service. Moving ahead, once we created the cluster, there were two nodes. One was the master node, another is the worker node, and it was successfully created. Now it was the time to deploy our app, our math service app, on these nodes, on this cluster. And here is the service configuration and the deployment configuration. For service configuration, these ports were important because these were the pretty much factors that were important while deploying anything. So this host port exposes the Kubernetes service on the specified port within the cluster, and other ports within the cluster can communicate with this server on the specified port. This target port is the port on which service they send the request to, and the pod will be listening on. So the application in the container will need to be listening on this port also. And node port exposes the service externally to the cluster by the means of target node's IP address. Uh, for the deployment part, we had to keep the image in the Docker hub. We had to push it there first, and then we have to pull it from there using this image pull policy always, which if it creates an error, then this image pull policy will help us pull that image in. Once we created that, so here are some lists of image that we created, and math service is one of them. We move on to the pods once we apply the deployment, and here are two pods. As the replicas that we mentioned in these were two, so two pods were created, and then to test it that our app is working or not. So here we use this command to describe the SVC, and after this we can test our app on the service. So now this is the most important part. um, as we have this 8080 as the host port, we need to use this along with the IP address of our SSH. So this will be the live testing. um, our instance has been listed here, and I'll use this 8080. So this is what we get. So we have been able to successfully deploy our application on the Kubernetes, and this is what somehow we were able to execute it completely. Now to test it even once, we have two pods, and for the sake of the time, I'm going to accelerate it by keeping a big thread. So let's keep it to 25, and I believe it will be faster. So here we can see that it's successfully working. It's successfully we are able to send the client request, and here we have the result. So this was the entire assignment. Thank you.